Okay, we're continuing with January 2012. They want to know the solution set for this, which is x equals. Now, one of your options is to plug all these values in. A good suggestion is to keep the x in parentheses. And then you can just keep doing second enter, and you can bring it down to keep checking. This has to come out to be 0. So say I'm going to the first one. I plug my 0 in. I check it. Then I put a -2 in. I check it. Then I put a +2 in. So far, so good. Then check the 3. That's not going to work. So you know you got these two. And this one's missing a 0. So there's your 2i. Plug in at least one of the 2i's. And make sure that it's also a 0. The second way to do this, the right way to do this algebraically, is to find your greatest common factor. So we're going to factor out a 3x. And we're left with x to the 4th minus 16 equals 0. This is perfect squares. So we're going to factor this. X squared minus 4 to x squared plus 4. This can factor again. X minus 2, x plus 2, and x squared plus 4. But you can't factor the x squared plus 4 because then that's not a perfect, it's perfect squares, but it's not separated by a minus sign. So we're going to leave that one. Each one of these gets set to 0. So x is 0, which we knew. X minus 2 is 0, so x is equal to 2. X plus 2 is 0, so x is equal to -2. And subtract the 4. When you take the square root, you get a plus or minus. Take out the -1, and there's your 2i. So there's all your values, which was in number 3. Number 17, a little bit tricky. You had to find the nth term. Now, the nth term is not given to you in a formula. You have to remember this. This one, it says you're looking for a sequence. You first have to determine, is it arithmetic, which are these two, or is this geometric, the ratio, which is this. So if I look between 4 and 10, I'm going to lay out my numbers, 4, 10, 25. Can I add something to get here to here and here to here? No. So I must have multiplied something by 4 to give me 10. So I multiplied it by 2.5. Now, multiply 10 by 2.5, you get 25. Just check. So you're in here, and they're both 2.5s. Your formula does state a to the n to find any position is a1 times your r to the n minus 1. This one you would have to know. You would have to know that it was this one. What you could do, if you wanted to, is try it out to see which one you get to 25 by using an a3 in here. Find a to the third, find a third 3 using this, and see which one works, this one or this one. And then you'll determine which one is good. Number 18 draws a parallelogram, so let's draw a parallelogram. Now, however you start this, just remember to go continuously around. Okay? So OL is 3.8, and it's also 3.8 on this side. LF is 7.4, and it's also 7.4 here. And angle O is 126, and it's also 126 over here. BL is drawn. They want the area of triangle BLF. Now that's a triangle with a side angle side, two sides in the included angle. You have a formula for this in the back. 1/2 AB sine C. Two sides and the included angle. So plug in your values. Doesn't matter what order you plug them in because you're multiplying. And because they want this rounded, you just have to plug this into your calculator. and you will get approximately 11.4. You didn't have to worry about too much of the rounding because the numbers are far enough off you can spot which one is your answer. Okay. Number 19 gives us the graph of your natural log. Put it in your calculator. Y equals E, and it raises it up there, and you put to the x. It is the log of somewhere between y equals 2 to the x and somewhere between y equals 3 to the x. So it follows your logarithmic laws. This passes through the 0, 1. This x-axis is an asymptote because it will never touch this. This is an increasing function, and it is in quadrants 1 and 2. So it's asymptotic to the x-axis. All real numbers, I can use any of these x's and hit that graph. It's in 1 and 2, and this one's wrong. It passes through the point 0, 1. So they said not true. Number 20 asks you for the degrees in a radian angle of 2 radians. Now, if you're used to looking at pi over 4 and converting it, do it with this one first. You would multiply by 180 over pi. So therefore, multiply 2 by 180 over pi. And you will get 360 over pi.
Could a custodian please come to the main office?
21 gives us a spinner divided into 8 sections, equal sections. 5 red, 3 green. Altogether, 8 sections. We want to know if the spinner is spun 3 times, I'm going to do this 3 times, what is the probability that I get exactly red 2 times? I want this to be exactly twice. Does it matter what order? No. There's your combinations. Here's your Bernoulli's, and it follows your pattern. Out of 3 of these, I want 2 to be successful. My probability of getting a red is 5 out of 8. My probability of not red is the rest, 3 out of 8. So you want to be successful. 5 out of 8, you want 2. 3 out of 8, you want 1. And just put it in your calculator. And flip it back to a fraction. Number 22 asks for a range. Range are your y values. This is an absolute value. Put this in your y equals. This is an absolute value function that was moved to the right 3 units and then up 2. This is the one that's going to change. That transformation is going to change your y. So you're going to see it up here at the 2 when y is equal to 2. So your range goes from 2 and above, greater than or equal to 2. Why such that? Number 23, not one of my favorites. Again, it asks us for the strongest correlation. This is your correlation coefficient. This is the R. We're going to look at all the R's. And they want the strongest one. Now, normally we say the highest number, whether it's positive or negative, because it falls this way. It could either be strong to the negative or strong to the positive. And they didn't tell us. So in looking at the highest number, we look at this one. However, this is where your slope is. So if this slope determines if your correlation is negative or positive, your slope would be this way. That would give you a negative correlation, but your B here is positive. So these two do not match. Therefore, it cannot be this one. So if we look at the next highest, it's this one, and b is positive in both cases. Not one of the questions that I was very fond of either. Now number 24 is also not one of my other favorites. They ask for this log to be defined in terms of log A. So let's get log A to one side. So we're going to start like this. The log of x squared is equal to, we're going to add log 2a to the other side. Now we know when we're adding that it really broke down from a multiply. So we're going to bring this out and we're going to multiply this. So this is going to give us log 6a squared. We're still looking at log x squared right now. Now, bring down your log x squared. And now we're going to take the 2 down. When we see this again, this is a product. This was an add, so we're going to separate this into log 6 plus log a squared, because now we got the a's together, all in one piece. Before we had them separated. So now we have them together, and we're going to bring that 2 down also. Now, to solve for x, we're going to divide everything by 2. This 2 comes out, and notice they just kept this 1/2. So your log x in terms of log a is 1/2 log 6 plus log a. It was kind of a little tricky, but try to get the a's to one side and then isolate a by itself. Once you got a by itself, you could solve in terms of a. Number 25 is actually a nice question. It asks if this function 1-to-1. 1-to-1 says it passes both a horizontal and a vertical test, for line tests. So graph each of these. They're y equals. There's your absolute value. Whoops, doesn't pass a horizontal. Here's an exponential. Oh, and that passes both your horizontal and your vertical line test. And you know your sine curve does not. And you know your parabola definitely does not. It's like the absolute value. 26 gives us a vary inversely. This says multiply. So the products have to remain the same. So plug them in. 10 times 3 over 2 is equal to 3 over 5 times p. That's the guy you want. And solve for p. Varies inversely always takes a product. The last one is a trig function, is a graph, but we're always used to looking at it where it comes down like this and across evenly this way. So the first thing we're going to do is find its resting point. Find the place where it's equal top and bottom, because this keeps on going, don't forget, it's a curve. So somewhere in the middle here, right about here, because if this is 8 and this is 2, you want the middle, divide by 2. You want it at 5. In other words, this x-axis translated 5 up to there. The y moved up 5. So right now we're going to look at either 2 or 4. So we can get rid of this, 1 and 2. Try to eliminate as much as possible. This is a cosine curve. They're all cosine. The amplitude now goes from 5 to 8, we got 3s. And this started on the bottom. This is your reflection. So there's your reflection right there. Just eliminate one step at a time.